Hello guys, so we will continue our discussion on position time graph, and this was the question that we were discussing last time, that what does each part of this graph represents. So if you see that this is the origin, and above this we have positive displacement, below this we have negative displacement. Therefore, negative displacement means that object is moving towards the left hand side. So imagine that if this is the origin, then object is moving towards negative x-axis. Yeah, this is negative x-axis. So if you look at part A, if you calculate the slope of part A, the slope would come out to be negative. That would mean that velocity is negative, and negative velocity means that object is moving towards the negative x direction that we see here in this part. Okay, what happens at B? It's obvious. Displacement is not changing with time. It remains same, so object is at rest. And what happens at C? In C, you see that the object is moving towards origin again. So it was at rest and then it is moving towards origin. So if I calculate slope of this part, that would come out to be positive. This whole region, this whole part of C means that object is moving towards origin, but it doesn't stop there. It keeps on moving towards right hand side. So that would mean that object was at rest here, and then it would move towards right hand side. It does not stop there, rather it continues to move. It continues to move towards right hand side. This is towards positive x-axis. Yeah, and at D it is at rest again. Yeah, so the answer is this, that in part A, object is moving away from origin in negative x direction. At B, it is at rest. At C, it moves towards origin in the positive x-axis, but it doesn't stop there. It continues to move in the positive x direction. And at D, it is at rest again. So this is the explanation of the position time graph that I gave you last time as a question. Now, this position time graph looks very simple. Yeah, so life is not simple, life is hard. So what happens if we have a position time graph like this? It's not a straight line. Yeah, it's a topsy-turvy line. So how do I explain what is happening to the motion of the object, where it is at rest, and how do we calculate the slope of this line? We cannot calculate the slope of a curved line. We can calculate slope of a straight line only. So what do we do here? So in this case, what we do is that we divide this graph into several smaller parts. We can divide it into many smaller parts, but broadly speaking, we will divide this line into three main smaller parts. So this is part A. I would say this is part A up to here. This is part A. Then from here to, let's say, suppose here, this is B part, and then we will have this part, we will call it C part. Yeah, so here in this part we see we have a flat line. That means object was at rest, and then slowly its velocity started to increase. In what direction? We have positive x-axis here, so that means object is moving away from the origin towards positive x-axis. And in part B, velocity continues to increase up to a certain the object continues to move towards a right hand side, with a constant velocity. So this is more or less a straight line. So this is a straight line. Yeah, so I can calculate its velocity easily. So this is going to be a constant velocity. So in this part, I would say that object continues to move towards positive x-axis, towards right hand side with a constant velocity, and then here the velocity starts decreasing again till it stops at this point. Yeah, so this part says that velocity is decreasing and object at this point your slope becomes 0 again. Okay, now how do I calculate the velocity? Imagine I want to calculate velocity between this point and this point. Now again the problem is that I don't have a straight line. So that problem can be solved by drawing a straight line. So I'm going to draw a straight line. I'm going to join these 2 points. I will join these 2 points with the help of a straight line. This is a straight line. Yeah, and I calculate the slope of this straight line by using the same formula, that is the rise over run. So this is run and this is rise. So I measure how much is my rise, I measure how much is my run, rise divided by run, that would give me velocity. Yeah, but important thing that you should understand here is that we have drawn a line from our side. Our actual displacement time curve or position time curve is this. This is the line that we have drawn. Therefore, the velocity that we will calculate from this curve will be average velocity. It is average velocity. The velocity that we have calculated here in this example, that was a constant velocity. I could calculate velocity, I could calculate slope at any 2 points. I chose these 2 points, but I could have chosen any 2 points. I would get 4 meters per second. Here, this velocity, this slope that I have calculated, this will give me an average velocity, right? It is not going to give me constant velocity. You can imagine that if I choose to calculate slope between these 2 points here, let's say these 2 points, the slope of these 2 points is going to be different. Yeah, therefore if you want to calculate average velocity, you are going to take 2 points which are at far away distance, and then you calculate the slope, and that would give you average velocity. Now in the comment section, Saria asked a very interesting question, that do you need to take 2 points to calculate slope? Can we calculate slope on a single point? The answer to that question is yes, you can calculate slope on a single point. So let's say we want to calculate slope on this single point. In that case, I'm going to draw a tangent line, and you know what is a tangent line. Tangent line is a line which touches only one point on the curve. So I will draw a tangent line like this. Yeah, this tangent line touches only one point, and then I will calculate the slope of this line, and that would give me velocity. But that velocity is not average velocity, that velocity is not constant velocity, that is instantaneous velocity. So remember, the definition of instantaneous velocity is that velocity in a shorter interval of time, shortest interval of time, and shortest interval of time in our course is 1 second. So this single point corresponds to 1 second only. Yeah, these 2 points correspond to a time interval. That time interval may be 10 seconds or 15 seconds or 5 seconds, whatever. This single point corresponds to 1 second only. So if I draw a tangent line, if I calculate the slope on a single point, that would give me instantaneous velocity. So I would write here that this tangent line gives me instantaneous velocity. So let's sum up our discussion. On this nice straight line, we get a constant velocity. If I calculate slope on this curved line by joining a straight line, by joining 2 points with the help of a straight line, that would give me average velocity. If I calculate slope on a single point, then that slope will give me instantaneous velocity. Right? So now you have to answer this question. So I have a position time graph. Again, we have positive displacement, negative displacement. This is origin. So you have to describe the position of the object at this point. This is point A. And remember, it's not a region, it's not a straight line, it's just a single point. Then you have to describe your position of the object at this point. This is point B. Describe the motion of the object at point C, at point D, and at point E. So you have to describe the motion, whether the object is going towards right hand side or towards left hand side, and its velocity is its motion, you are calculating a constant instantaneous velocity or constant velocity or average velocity, right? So do you hear a baby crying? This probably is my daughter. Yeah, so let me see her, what is happening to her, and we'll meet again for the next video. See you later then.